Algebra-based physics, quantum physics, and atomic models. We'll start by talking about electrons, and then blackbody radiation, quantized energy, and the photoelectric effect, still dealing with electrons for the most part. Then atomic models, and then we start getting into quantum with waves and particles, a little bit on quantum mechanics here, and then finally several solved problems worked out step by step. Electrons. Physics by the end of the 19th century was thought to be pretty well understood. Newtonian mechanics had been in place for several hundred years. Maxwell's equations were the culmination of work done over several centuries and showed that electricity and magnetism were really the same force. Thermodynamics. Heat is just another form of energy and can be transferred into mechanical energy, or mechanical energy can be transferred into thermal energy. The speed of light was measured, and it was found not to require a stationary reference frame or a medium, which was named luminiferous ether, to travel through. This helped lead to Einstein's special theory of relativity in 1905. So many physicists were comfortable, not all of them certainly, but many were comfortable that nearly everything had been discovered and explained. But then things started popping up, like the electron. About 150 years ago, cathode rays were discovered, and we'll soon see why the quotes are around the words cathode rays. No one knew what they were. Physicists working on the problem just knew what they could observe, which of course is always a great way to study. Do experiments, see things, do more experiments. What they saw was that when you put a high voltage on two plates inside a glass tube, making one plate positive and the other negative, then they would see a shadow cast on the glass behind the positive plate. Furthermore, the glass surrounding the shadow glowed. When more air was pumped out of the tube, getting closer to a vacuum, and the glass was treated with special fluorescent chemicals, the effect was enhanced. It would glow more. This seemed to mean that something was traveling in a straight line from the negative plate, the cathode, and that's over here. Here's your cathode. And you have a negative potential here. And these rays, these cathode rays is what they call them, were traveling from the cathode to the anode. And a lot of times you'll see pictures, they use a Maltese cross here for effect. And then this positive plate, the anode, the metal cross, seemed to stop the rays, so you'd see a shadow over here on the other side of the glass tube. And as we just said, since the rays seemed to come from the cathode, they were called cathode rays. If you click on this YouTube website here, you'll see a nice demonstration of this effect. Once an experiment is performed, people want to explain what happened. So in this case, where we had these rays or something leaving the cathode, striking the anode, and then having the shadow appear on the other side of the glass, what's going on here? Well, light casts the shadow, so it could be light, or it could be a stream of invisible particles that are getting stopped by the anode, and only the particles that don't hit it and go by get through to the glass, thus forming the shadow. Could be either one. Now pretend you're 150 years in the past. What two ways could you check to see if the rays were charged particles? We've covered some of this material earlier in the course, so hopefully you'll come up with some ideas. One rule, you cannot open up the glass tube. So please take a couple minutes and discuss this in your group. One idea would be to apply an electric field across the path of the rays. We've already seen how an electric field will exert a force on positive and negatively charged particles. So in this case, if you have charged particles, they will be deflected by the field. Here's our field right here. We have a positive and a negative plate, so the electric field lines go from positive to negative. Now, the direction that they get deflected will indicate whether they're negative or positive. And if they don't have a charge, we would expect them to go right through the middle and not be deflected at all.